Hey y'all, it's me, Miss B, and today we are talking about limits. So this is first our introduction to limits, and limits are really getting into the calculus side of pre-calculus. So first, what is a limit? A limit is simply a value that a function approaches. In other words, what y value does the function intend to have for a given x value? So, the y value would then be our limit. Okay, we can use three different things to find limits. We can use a graph, we can use algebra, and we can use a table. And all three have a purpose in what we're doing. So we'll talk about all three of these methods as we move through these notes. So here's our first example, and it's f of x equals x squared. So I'm going to go ahead and graph that really fast. I'm going to use black just because that way it looks seamless. Let's go off. Okay. There's our parabola. And it says, what is the limit of f of x as x approaches 2? So I'm going to go ahead and write that out. I'm just going to say it one more time. So what is the limit of f of x as x approaches 2? So in other words, what value does the function intend to have at x equals 2? And this intend to have is going to come into play in just a minute. With this problem, I'm going to go to where x equals 2. And I'm going to say, okay, what does it look like x is going to be at that, or what is y going to be at that point? Now with this, it's easily just 4. That point is just 4. So this is 4. Okay, because f of x equals x squared. So we can write this as the limit as x approaches 2 of x squared equal to 4. Okay, and so we're just going to define some of these values here. So this 2, that number right there, that is going to be the value you want to evaluate. I spelled evaluate wrong. Evaluate the function at. I did my sentence in a preposition, but it's okay. All right, then in orange, that is our function. And then finally in blue, that's our answer. So really the only new piece of information is that the value you want to evaluate at is that green number sign. I think my pen just died. Yep, cool. There we go. Okay, so now let's talk about two-sided limits. So two-sided limits are coming from two sides, and in order for a two-sided limit to exist, the function has to approach the same value from the left and the right. So I always like to think of it as popping a pimple, which is kind of gross, but you will see how that kind of works. All right, and so I'm gonna add some text boxes here. Where did it go? Dang it. Okay. All right, so back to our pen. Okay, so in order for two-sided limits, we have to go from the left and the right. So here in this green, I have a piecewise function. You can go ahead and draw that piecewise function yourself there. So what we are going to do is we're going to see where it's coming from the left and from, if I can pick this up. Nope, I guess I can't. Gosh darn it. Ah. Well, I thought this would work. There we go. And from the right. So it's kind of underneath there, but you can see that those fingers are going to move past each other and they're never going to touch. And so because of that, the limit as x approaches 3 of this function that I made up, f of x, is not going to exist. So does not exist. So we can go ahead and write DNE for that answer. Does not exist, because those fingers are just going to slip right past each other, as if when we move our fingers on the left side and the right side, popping that pimple, they will never touch. Okay? So let's look at these few examples down here. So if I were to, I'm going to drag these hands down. Okay, so I'm looking at the limit of f of x as x approaches 3. So I'm going to go ahead and, oh, I don't know how I just did that. Okay, nope. Okay, so here's 3 right here. There's coming from the left. Here's coming from the right. And you can see as we move in together that both the left, from the left and the right, it is approaching 6. Oh my gosh, what is going on? So this value, as x approaches 3, it's approaching 6 for that y, well, like 6.1 for that y value, 6.2. Okay, we'll just make kind of a guesstimate there. All right, I'm over these hands. They're not really doing what I want them to do. So if I can move them out of the way, that'd be great. Okay, but you can kind of see what I mean by the pimple popping. Okay, so then let's go ahead and look as x approaches -2. Here's -2 from the left and from the right. You'll see that there is a hole there, and there's even a value down here. But when we're talking about as a whole, approaching from the left and the right, moving towards that 2, it's approaching 5. And then we want to talk about the limit as x approaches 4. So again, from the left, it's approaching 7. From the right, it's approaching 7. So that value is 7. Okay, this one's a little bit more interesting because we're going to talk about some different values here. Okay, so limit as x approaches 0. So from the left approaching 0 for x, approaching 0 for x on the right, it's approaching -4 for its y value. Looking at negative, let's turn that to +3. Looking at +3, it's approaching 2 from the left and 2 from the right. However, f of 3, the function at 3, it's this right here where it actually equals something. So that is equal to -5. Okay, so the limit as x approaches 3 is not equal to, oh, let me put f of x in here, of f of x is not equal to f of 3. Okay, so sometimes those values don't always line up. All right, and that is all for today, folks.